As Francisco said, I'm not going to talk about buildings or the whole products, but I'm going to talk about what's inside of every cooling machine, the blood of the cooling system, and that's the refrigerants. Maybe you are all familiar with the F-gas regulation. F-gases are the most commonly used refrigerants in the world, especially in the 90s and early 2000s. Unfortunately, these fluorinated gases, or fortunately, they were safe and efficient, but unfortunately, they have high GWP value, and the European regulation aims to phase them out. This is the phase down of the current or the current status of the phase down of the F gases. The orange columns, as you can see, were the previous phase down, and since last year the new regulation came into force, and in the blue columns you can see the new phase down of F gases. Why I'm showing this is that as you can see, there's some total quota of the F gases that are allowed to enter the common market of the EU, and the market, the producers, were planning in advance, of course, and they need to have some strategy how to deal with refrigerants and the amount of the refrigerants they will have. And the new regulation speeds this process up quite a lot. Between 2025 and 2030, the decline of the total quota will drop by 75% to roughly 5% compared with the year 2015. So this process is really fast. I always say that we as an industry, we are reducing the F gases or the carbon footprint really fast. So we are doing a really good job, and I hope this scheme will work out. So what it means in the market or on the market, that these refrigerants are of course getting scarce, and their value is getting higher. The price is growing, and 15 years ago, the refrigerant cost was so low that no one really thought about like reclaiming and using them again. Now it's something different. The cost, the value of the refrigerant is pretty high, and so the schemes for reusing them have started, and I would like to show you how it looks like, especially on the Czech market, because I have the deepest insight into the Czech market in here. So the regulation 573 of the F gases says that the recovery of F gases is mandatory. That means that during the service or end of the life of every product that contains fluorinated greenhouse gases, the gases have to be recovered. There are two types basically of that recovery. In big plants at the end of the life of the product, where the products are collected and then the refrigerants recovered. With larger products and on-site work, the recovery is usually done by a refrigeration mechanic. These people have to be certified. They have to have the skills and knowledge how to work and how to handle these gases. That's what we do. We train and certify them in our association. And the recovered fluorinated greenhouse gases can or should be used again. And the regulation gives us some basic rules how to do it, the procedures. It's not easy. It's quite a new system, and it's got some childhood sicknesses. but I hope as it develops, it will become more efficient. And also, national and state legislations on waste management and transport must be considered when you are handling recovered refrigerants. So what comes into play is also a ban on the use of new refrigerants or new F-gases. We call them virgin F-gases. The previous and now the regulation that's forced in nowadays says that some refrigerants that have really high GWP value, higher than 2,500, cannot be used for service or in new systems, and there are some exemptions, as you can see. And for servicing of the systems in operation, you have to use reclaimed refrigerant. There's an exemption, as you can see, on systems going under minus 50 degrees or refrigeration circuits used on weapon systems. And in the year 2032, this ban will become more strict, and the level of the global warming potential will be set at 750. So the refrigerants commonly used now, like R407, R448, 449, and the others, will be affected by this ban. And again, we will have to use, if you want to keep those systems running, we will have to use reclaimed and recovered and reclaimed refrigerants. These bans affect only stationary refrigeration systems. They don't affect air conditioning or heat pumps, and they don't also affect chillers. So what does it say? The refrigerants, whether new or reclaimed or repackaged, are considered acceptable for use in refrigeration and air conditioning products if they meet the purity levels defined in an AHRI standard. There is a standard. If you want to reuse the gas again, you need to be sure that the refrigerant has a certain quality, it's clean, and the compounds, if there are any, are set in the values that they should be. So it's not really easy to keep this. In 2025, there are only three companies in the EU, which can do reclamation of refrigerant blends, like R404A, 407, 410A, and these companies have their regeneration plants in Germany, Netherlands, and Poland. I said I won't be mentioning any company names. Let's say they start with A, D, and P. Their capacity so far has been increased, so they should be, they say they should be ready for the higher demand once the bans and the phase down comes in. And so far there have been no reports of lack of reclaimed F-gases. That's the reality. And altogether, these three companies, the plants, are able to reclaim, and you can see I don't have the number in there. I called and I asked, the values are confidential. So, but I made my own calculations, and it looks like the number is about 1,000 metric tons of refrigerants a year that could be reclaimed in all of three put together. Maybe a bit more, maybe a bit less. So we need to have a collective system to work for refrigerants. And the scheme is easy. You supply the refrigerant, you use it, then the certified person recovers it, and then you can reclaim it again if it's good for reclamation, or you can destroy it if it's not good for reclamation. So who decides if it's good or not? It's the refrigeration guy. You can see in the picture, this is some kind of a scheme he will use during his job. So he comes to a refrigeration circuit that's at the end of the life, or maybe there was a failure, and he has to change a compressor, for example, and he's dealing with he has to recover the refrigerant, and these guys should have the expertise to decide whether the refrigerant can be used again, is okay, is clean, or it should be tested for other use, or maybe it's too bad that it needs to be destroyed. So these guys have to decide. And in the scheme, you can see if they say, okay, the refrigerant is okay to be used again, then they can filter it. You can see with the machine they have, there's like a little gray filter. If you filter the refrigerant and then you decide that it's okay to be used, then this refrigerant can be used for service at the same company, at the same service company, or at the same customer who owns maybe another system. If it's not okay to be used again, the refrigeration company, servicing company, is responsible for the refrigerant as a waste, and it has to be disposed, must be disposed. The problem is that in this case, the recovered refrigerant becomes automatically dangerous waste, and transporting dangerous waste is not an easy procedure. If it's not good for or after basic filtering, but the refrigeration guy decides, okay, maybe after better purification it can be used. So he collects it into like a pressure vessel, and then takes it to their company or maybe partner company to be checked at a lab. The lab makes tests. Okay, this refrigerant can be reclaimed or cannot be, or maybe parts can be reclaimed, and then they send it to the 3 facilities I was talking about, and then they have this big chemical machines where they will just purify the refrigerant, and if it has compounds, they will take the individual compounds, make them apart, and then put together in the volumes that they should be according to those standards. So it's kind of a complicated process, and for the refrigeration guys, for the refrigeration mechanics, it's kind of a burden. It costs them work, it costs them money, and it costs them time. So there must be a motivation for them to do it. Otherwise, without the motivation, and that's the reality, they just open the valves, the refrigerant goes out, and they said, okay, it was empty when I came, and nothing happens. It's easy solution for them, but it's not the solution we want for the environment. So how do the collective systems or schemes work in Czech Republic right now? There are 2 points of view. One could be a service company level. So when the service companies work with their refrigerant suppliers to buy new and reclaimed refrigerants, these companies, there are like 7 in Czechia, they also collect recovered refrigerants. After recovery, service company transport the refrigerants in bottles to their suppliers, and then these companies make tests and then transport it to reclamation works. The tests usually take about 2 to 4 weeks. So when a company gives the refrigeration to this collective system, they have to wait a couple of weeks to get some refrigerant back. sometimes the collective system works on a larger amount, so they need to wait until a larger amount of refrigerant is collected and they can transport it. Only these refrigerants, you can see 404A, 134A, 407, and 410A, are accepted for reclamation right now in this year in Czech Republic. In 2024, two largest companies in Czech Republic collected about 5 tons of HFCs for reclamation and sold about 6 tons of reclaimed refrigerants. So you can see the demand is slightly bigger than the number of the refrigerants that's being collected. Recovered and later reclaimed refrigerant is 3 times cheaper than reclaimed refrigerant bought from a dealer. So if a company recovers the refrigerant and then makes all the procedures to reclaim the refrigerant again, it is cheaper for them than if they buy like bottles of recovered refrigerants. So that's the motivation for them. And service companies buy almost only reclaimed 404A because it's got high GWP value, and you cannot use new refrigerant or virgin refrigerant like that. There is a demand for 410A, which is used mainly in air conditioning systems, but it's now not available on the market. So if it was on the market, the companies would use it and buy it. And there is an operator level. It means the owners of the systems who can use this system. There's one company who runs a collective system like that. It's aimed at operators of the systems, but only for selected key customers, usually international companies, corporate companies. HFCs are recovered from all units on the cost of the operators. The company doesn't pay for the waste and gets credits for future new installations. So they get like a carbon credits. So in the future, when they buy a new products, they might get some kind of a sale or on that. Recovered refrigerant is taken to reclamation plant, purified and mixed with virgin refrigerant if needed. And then reclaimed refrigerant is then filled into new units in production plant. This system works for R410A, 407, 134A, and there is a plan to do it, to run it for R32 in the near future. Hundreds of kilograms of such refrigerants were collected in the Czech Republic last year. In Austria, it works also, and there it was tons of refrigerant that were collected like that. So the question marks to the future: will the system collect enough recovered gases? We don't know. We hope. So far, it works. Will reclaimed refrigerants be competitive on the market? I hope so. There is a big question mark about the quality of those refrigerants. Will producers want to use the reclaimed refrigerants? This is a question to you. Will you trust? Will you want to use it? I hope so. And will member states be able to protect the market against illegal refrigerants, HFCs? This is the biggest problem, I think. The black market with refrigerants is blooming. And if you want the phase down to work, we need member states and the authorities to police the regulation. Thank you.